Have a good day. In this video, I will consider solution strategies for the minimum edit distance problem and matrix chain multiplication problem. First, I choose the name of my function as min edit distance and introduce the variables of this function as shown here. The first input string of length m a. The second input string of length n is b. So we have considered three different scenarios with an optimal alignment in mind. If we only need to add any letters from the first string, we defined this case as shown. If we only need to delete any letters from the second string, we define this case as shown. Or if we only need to use the last letters of both string, we define this case of as follows. So I write all of them here with the base case. Base case are if first strings is empty, the only option is to insert all characters of second string into first and vice versa. If last characters of two strings are same, no operation needed. Get the count for remaining strings just. In here, else means last character are not same. Consider all three operations on last character or first. Recursively compute minimum cost for all three operations and take minimum of three values. When comparing, when we write this method, it can be used for solution, but there are overlapping methods and time complexity is much big, which is 3 over n plus m. I write also dynamic solution here, and I will introduce dynamic solution also. Firstly, we need to create a table like this. After that, write 2 of 4 loop and write base cases. Base cases do the same thing, and there is a condition for matched characters also. When comparing letters, I actually show on table. I can explain much better. At the beginning of the filling table, base cases are used. Here, base cases 1, 3, 4, and 5 are filled like that. After that, when comparing letters, if it mates, for example, S and S, we write the value in the diagonal cell because we have a condition for check. Here's a condition. If it doesn't match, we want a minimum value of 3 cell. For example, here N and U doesn't match. We compare the 3 cell here 1, 0, and 1, and add 1. We add 1 to the minimum value of 3 cell which we compared, and add it to the current cell in here after the filling table. The result is the last cell. I already highlighted it. After that, our complexities become m plus n. Let's focus on the matrix chain multiplication problem. The main goal of this problem is to find the minimum number of operations needed to multiply a chain of matrices. As in the previous problem, we have the variables and their explanation in parts A and parts B. Let's focus on the one of the cases we need to imagine for optimal division. In the first case, let's assume that in order for the operations to be minimal, they only need to be split at the first index. In this stage, we solve two subproblems to calculate the minimum number of operations needed to multiply the matrix chain from I to J. In the first subproblem, we get the minimum number of operation to multiply the matrix chain from I to 1. In the second subproblem, we get the minimum number of the operation need to multiply from I to J. After adding these two values, we need to perform an additional operation to multiply these two matrix chains, and we calculate this number of operations and return the sums of these value. We use the same logic here. We calculate number and return it. After that, we try different values of k get the smallest number of operations. Also, I want to mention the result variable with integer max value, because this value indicates that no solution has been founded yet. For each value of k, a computation cost is calculated, and result holds the smallest value among these costs. That is, we try all values of k to get the smallest number of operations. This solution can be lead to solving the same problem repeatedly and time complexity too high, which is 2 over n. I did dynamic programming again for it. In dynamic solution, we create a table which is 2-dimension, and we should fill the table according to correct conditions. I just want to give an example with matrix chain, which is dimensions are 5, 4, 6, 2, and 7. After creating a table, the subproblems, the result is given at DPU1 n-1. I already highlighted it. The time complexity of program decreased 2 over n to n over 3. Thanks for listening me. Have a good day.